Welcome back to my channel, everyone. Sri Tips here, and a good friend of mine, Joe Birnbaum, also known as Computer Guy, ND Computer Guy on YouTube, donated these IC chips to me, gave them to me. And so we're going to try to do a recovery on these. I've got a 2 bags here. Let's tear the scale with this empty bag. And now we'll put our chips up here and get a weight on this. Looks like we've got 1,012.3 grams of IC computer chips. What we're going to do now is try to do a recovery on these and see if we can get some gold out of them. Let's go ahead and dump these into a container. That's what they look like. IC computer chips. Dump them right in here. Take a look and see what we got. I've never worked with these. I have no experience. Joe sent an outline of how to process those, and so that's what we're going to do. The first step is to burn these chips. So we're going to fill up a melt dish. Got this set up next to my fume hood. There is some smoke coming off of these things. And the time right now, we just put those in. The time right now is about 2:45 p.m. These have been in here for about 20 minutes. I'm gonna open this up and see what we got in here. Oh yeah, they're nice and hot, ready to come out. So now what I'll do, so I've got another melt dish up here. I'm gonna dump these that have already been burnt to this dish here. They still look black. Might have to burn those again. Set this off to the side. Now what we'll do is fill this up.
I don't know if we're getting these hot enough to burn all the combustible material off. These over here still look kind of black, so I may have to revise this process and burn these things a second time. I think I'm crowding the melt dish. And I'm not getting a good burn on these chips. So what we'll do, let's put dark ones back in, just a few at a time, not too much. And this is going to take a while to do all this. I think this is how they're supposed to look. White. So I'm going to have to go through the rest of those and burn them a second time. What I'm doing is putting small quantities of the chips in these melt dishes. And then I've got these look pretty good. Nice and white color. What we'll do then is transfer some of these. Not many. See how black they are? Those need to be burnt so they're white. And then I'll just spread them out over the bottom of the dish so that they can have access to the air and the heat inside the furnace. And what that should do is burn those things completely so we can process them later on.
I've been at this about 5 hours now, and I think what we're going to do is shut this down right now. I've been out here 5 hours, and I really can't see how anyone would spend all this time to do this. I've got it about half done. This is still got to be burnt, all this, and this has already been burnt and ready to process. So we'll continue in the morning. Tomorrow morning, I've got the furnace fired back up. These chips have all been burnt proper, and I think, judging by the way they crush into a powder, that I'll be able to take these and break them up in a mortar and pestle. So I think we're going to be okay with the way these have been burnt. These have been burnt once, but they're still black and they need to be burnt again. So we're gonna continue that. I've got these 2 melt dishes prepared with chips already in them. And that's how many we're gonna be burning at a time in order to be able to get them to burn completely. Finally got everything burnt. It's taken about 5.5 hours yesterday and about 4 hours today. And so about 9 hours total. I've turned the furnace off. We'll wait for all this to cool down. Here we go. We're gonna chop these computer chips up now in a mortar and pestle, and then pour them through this wire mesh, strain them all out. This is taking too long with the mortar and pestle. The instructions he sent with the lot said to try using a blender. And so that's what we're gonna try to do. We're gonna try to use a blender to chop this up. I guess we'll start off with the material that's too big to go through the screen here. Put that in here and see what happens. Here we go. See what happens. Seems to be working okay. I'm gonna add some of this these chips in here now. Give it a spin. Into our screen over here. Chopped it up pretty good, I guess. got a good bit of powder in here. And I've got some pieces down here that just will not crush up no matter how hard I hit it with the mortar pestle. There's a ton of magnetic stuff in here. Magnet down here and see if we get any magnetic stuff from this powder. We do. See that? Do an experiment here before I go all in with this powder. I'm going to get a little bit of it in this scoop. I'm going to put it in this beaker. Get this out of the way. We're going to take this material here that I could not grind up any further. I'm going to stick it in this beaker. Go ahead and put some distilled water in this beaker. I'm adding some nitric acid. Give this a stir. Now we're going to add a little bit of this dilute nitric acid to this over here. And we'll add some to this beaker with our powder in it. Cover these up and let them react for a few minutes without any heat. It's getting late. I'm going to turn these off and let them cool down. And then we're going to get in here and see what we got going on inside these beakers. My stannous chloride expired. I made it 30 December of 2024. So what we're going to do is make some fresh stannous chloride testing solution. We do that with about 1.5 grams of pure tin shot. Bought that on eBay. And then we're going to have about 1.5 grams or so of some stannous chloride crystals, which is going to be about that much. And now we'll pour this into our testing solution jar here. we go. We got it in this bottle. There's the recipe. About 1 gram of pure tin shot, 1 gram of stannous chloride crystals, 25 milliliters distilled water, and 30 drops of hydrochloric acid. So now we're going to add some distilled water to about right here, which is 25 milliliters. And now I've got hydrochloric acid. This is a Pt1 drip tip bottle. So we're going to count out 30 drops. Doesn't have to be exact. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 4 to 5 to 6 to 7 to 8 to 9, 30 drops of hydrochloric acid. Then we shake this up and it's ready to use. Let's test it out now. Make sure it's got the right potency to it. Got a piece of filter paper here. This is a gold testing solution, 1 gram per liter gold, and I use it as a test standard to test the validity or the accuracy of my testing solution. We just made this. Let's test and make sure it is potent. Boom, there you can tell. It's created a dark stain. This is our solutions. I'm going to dip a piece of filter paper in here. We're going to use some of our freshly prepared stannous chloride testing solution. Let's see if we've got any precious metals in solution here. I don't see anything. Maybe a trace. Do the same test on these solids. These have been boiled in nitric acid. Let's do a test on this, see if we've got anything in solution here. Any precious metals. I don't see anything there either. So it doesn't look like either one of these reactions in these beakers have anything in them. This one, that was from beaker number 1. Looks like it might have just a touch of something in there, but it's not enough to try to recover it and refine it. I'm gonna reach in here and get a little bit of the solution into a small beaker. It's blue, I believe, because we've probably got some copper in this solution. And we'll do the same thing over here with this solution. This one's green. And that could be an indication that we may have some palladium in here. Simple test for silver in solution. I'm adding some hydrochloric acid from a Pt1 drip tip container. If there's any silver in here, we'll see a white cloud of silver chloride forming. And we've got something in there that's turned white. Let that settle out. Do the same with this one. Just adding some drops of hydrochloric acid. If there's silver in here, we should see a precipitate form. And I don't see anything. Maybe a little. Just a tiny amount. Reach in here and get another sample of this liquid to a clean beaker. Got some DMG in this little container, and it's in water. And what I've done is heated it in the microwave because the DMG does not like to dissolve very well in the water. But we should get enough of it in this for this test. What we're going to do is add some DMG to this and watch for a precipitate to form that could indicate that we have palladium. I don't see anything in here that looks like a yellow precipitate that would form on adding DMG to indicate palladium. So my diagnosis here is there's no palladium in this solution. A bit more of this solution to our dropper here. Now let's test this for the presence of iron, ammonium thiocyanate. Is a sensitive test for iron. I'm going to put a few crystals of this in a spot plate. Add a drop of our solution. Copper is blue in solution. Iron is yellow in solution. Yellow and blue make green, so we may be looking at some iron here. I'm going to add a drop of it to this ammonium thiocyanate. If we've got any iron in here, it should turn a bright red color. It does not. It turns black. Now let's check for nickel. I'm going to put a drop of our solution in a spot plate here. And then I've got some ammonia. And we're going to neutralize the nitric acid with a few drops of ammonia. Oh, look how it turns blue, man. Blue is indication of copper. According to the book, we add a drop of DMG to this solution after we've added the ammonia to neutralize it. If it turns pink, that's an indication that we have nickel. It's wanting to. I can see it turning yellow, or I mean a red color. So that's it's purple because there's blue in there. But that's an indication that we probably got some nickel in solution and with those solids from the nitric acid boil. After I dump this in the waste bucket, you can see there's a pink stain down at the bottom of that cavity that held our solution. That's a further indication that we had nickel in that solution. Safe to conclude that we probably got some nickel, at least in this one. I didn't test this one for nickel, but we've got some nickel in this one, and both of the solutions have a little bit of silver in them. It's that little fine white line down on the bottom of the beaker. That's an indication of a little bit of silver chloride that formed when we added the hydrochloric acid. Nothing in these solutions that I want to keep or try to recover. A little bit of silver. There's not enough silver in there to try to do anything with that. So I've got my vacuum bottle set up here. Now what we'll do is pull both of these solutions off the solids in each beaker into my vacuum bottle. We got that done. Got the solution pulled off. What I think we'll do now is just combine the contents of each one of these beakers. Here's the solids. Just going to dump this right on in with the powder that we had. We'll go ahead and rinse this off, and we'll let this settle out a bit. Draw that solution off the solids. The solids have settled out of this rinse water. So now what we'll do is go ahead and get the rest of that liquid off of these solids. Here's our solids. What I'm going to do now is set it up here on our heat source, and we're going to add some hydrochloric acid Fill it up to about, let's go to the 250 milliliter level. Here you can see the solids down on the bottom of our beaker. And so what we're going to do is we're going to add a little bit of heat now. I've got some nitric acid here. There's probably about 20 or 30 milliliters in this bottle. What we'll do is put this on time lapse, and I'll add the nitric acid in. I don't want to add it in too fast. I don't know what's in here. I don't know how this is going to react. So we'll add it in slowly, and as it heats up, we're going to form aqua regia in here and see if we can put some precious metals in solution. This is the powder that we sifted out of the IC chips, and based on that earlier test when we did the nitric boil, I don't think there's any need to do that for this powder. So what I'm going to do is add some hydrochloric acid. I'm going to add it straight in, and we're going to start processing this powder while we wait for the other beaker to react. I'm going to add a little bit more hydrochloric acid, and then I'll reach in here and stir this up with a glass rod. Make sure everything's wet with the acid. I'm going to add a shot of nitric acid in here, maybe about 50 to 70 milliliters of nitric acid. Now we're going to stir this up. And I'll set this up on the heat now. And we'll start processing this material. I got to reach over the top of this other camera that's in my way. Set this up on the heat and put it on a low heat. Now we'll cover this up and let this cook. Both of these beakers have been unboiling now for a couple hours. I'm going to turn the heat off. We'll let these cool down and get in here and see exactly what it is that we have in these beakers. Let's reach in here with some piece of filter paper. Get some of our solution on here. Check it with stannous chloride, see if we've got anything in solution. That's got a purple stain going on. So we've got some gold in this solution. Not a whole lot, but I mean, that's a purple stain. That's what we want to see. We'll do the same for this beaker. Let's see what we got going on in here. Oh, we've got a dark stain on that one too. Pretty decent. Not bad. Purple, indicating we've got gold in solution. Fill this tube with some distilled water and siphon the solutions down into this filter. Finally got all the liquid pulled through there. That's all our gold bearing solution down in the flask. I've got more back in here that's got some solids in it. I got some more to pull through the filter here, and I'm gonna call it. And what we'll do is pick up with part 2. We're gonna call this part 1, pick up with part 2 tomorrow. Thank you for watching.